38, 39, and 40 on B02 Science. 38. The question is, the discovery of which of the following features in the Chrysoplanitia, if made today, would provide the best support for scientist 2's viewpoint? We need to read and understand the question and answer choices. F says a thick frozen H2O layer. Would that support scientist 2 viewpoint? G is also about H2O, but it says a large lake of liquid H2O. All right, let's look up at scientist 2 and see what this scientist has to say about H2O. The first paragraph, I don't see anything H2O. CO2 and H2O stick out like a sore thumb. Down in the second paragraph, it says, since Mars formation, I'm looking for my pen as I'm talking. Its average surface temperature has never been greater than negative 50 degrees Celsius. This has made it impossible for a significant amount of liquid H2O. So there's no liquid H2O. Now, the rest of this paragraph doesn't mention, what is it, solid? Yeah, frozen H2O. Not solid, but frozen. So G is out. Liquid H2O is out. It doesn't specifically mention frozen, but it does say negative 50. So I'm going to put a question mark next to F, and it's hard to make a question mark on here. But there's our question mark. We're not sure about F. All right, then it says 3.5 billion year old mountain or 3.5 billion year old impact crater. So we're looking for mountain or impact crater. Now this says before 3 BYA. What does BYA mean? I might look up above and see if they tell us what BYA means. Up here, it says the channels. I'm right here. The channels, some of which are 100 kilometers long, were formed more than 3 billion years ago, BYA. So BYA means billion years ago, and we're looking for mountain or we're looking for crater. Before 3 BYA, large volumes of gas were present. Eventually, the pressure due to the weight of the rocks and soil became great enough to change the CO2 to a liquid. No mention of a mountain or a crater. When a later major event, such as an asteroid impact, removed most of the overlying material. Asteroid impact goes along with impact crater, and now we realize there is no mention of frozen H2O, so we can really eliminate F. H is out because they didn't mention a mountain. Scientists, too, did mention a 3.5 billion year old impact crater. Well, actually, prior to 3 BYA billion years ago, this asteroid impact. So that is answer J, supports scientists 2. I would suppose if J wasn't there, then maybe F would be a good answer. But really, scientist 2 doesn't mention a thick frozen H2O layer. And let's look at 39. Suppose liquid H2O was present on Mars' surface prior to 3 BYA, billion years ago. Would scientist 1 agree that gray hematite might have been present on the surface prior to 3 billion years ago? And would scientists 2 agree that carbonate rock might have been present on Mars' surface prior to 3 billion years ago? And then we have every combination. 1 says yes, 2 says yes, 1 yes, 2 no, 1 no, 2 yes, 1 no, 2 no. All right, so let's check scientist 1 first. If liquid H2O was present, would scientist 1 agree that gray hematite might have been present on Mars' surface? So let's check. It says, unlike today, Mars was warm enough prior to 3 billion years ago, so that's the right time frame, for liquid H2O to exist on the surface. So it says liquid H2O. And now we're looking for hematite down here. Gray hematite, a mineral, is abundant on Mars' surface within the Chrysoplanitia. On Earth, this mineral is associated exclusively with liquid H2O. So if there were liquid H2O, if there was liquid H2O prior to 3 billion years ago, scientist 1 would agree that gray hematite might have been present because it's associated with liquid H2O. So C and D are out, and it's got to be A or B. Well, that doesn't help us with 2 because A or B is yes or no for 2. So we just have to check it out. Would scientists 2 agree that carbonate rock might have been present on Mars' surface prior to 3 billion years ago? All right, carbonate rock. Well, the first paragraph talks about carbon dioxide. So before 3 BYA, large volumes of CO2 gas were present a short distance, and we're looking for carbonate rock. I forgot about that for a second. So where am I going to find carbonate rock? Well, it's actually not in the first paragraph. It's in the second paragraph. If any liquid H2O had been present, I'm reading right here, had been present on Mars's surface, it would have reacted with CO2 to produce carbonate rock. I was just looking for carbonate rock. So it says if liquid H2O had been present, there would have been carbonate rock. So 2 has to be a yes, and that is answer A. I mean, you can either eliminate, those 2 are out for 2, these 2 are out for 1. So the only one that doesn't have one or the other one eliminated is A, or you realize both are yes. So the answer is A, yes and yes. Number 40, based on, remember, think simple. Based on scientist 2's discussion, did the pressure of rock and soil on subsurface CO2 have the effect of increasing the average distance between CO2 molecules or of decreasing the distance between CO2 molecules, the average distance? F is increasing because CO2 changed from liquid to gas. G is increasing, CO2 changed from gas to liquid. H is decreasing because CO2 changed from liquid to gas. J is decreasing because CO2 changed from gas to liquid. Well, there's one thing that you probably know about the distance between molecules. In a gas, the distance between molecules is greater than it is for a liquid. So a gas may look something like this. They're pretty far apart. In a liquid, it's hard to draw these dots for some reason in this program. But a liquid, the molecules are much closer together. It's denser. Liquid is denser than gas. So we imagine, maybe it says something different, but just guessing based on what I know, it has to be decreasing the average distance. If it was going from gas to liquid, and if it was going from liquid to gas, it would be increasing the average distance. So let's see if we can find that. It says according to scientist 2. All right, scientist 2 says before 3-BUIA, large volumes of CO2 gas were present. So it started as gas. The subsurface pressure due to the weight of the overlying rocks and soil became great enough to change it to a liquid. So it went from gas to liquid. Now, based on what we know, that means that it had to decrease the distance between the molecules. But who knows? Maybe scientist 2 contradicts that, because we have to go by what these scientists believe, not necessarily by what we know. When a large event, such as an asteroid impact, removed most of the underlying material, the liquid CO2 moved to the top. The CO2 carried rocks on Earth. Gases or liquids have been under pressure, are released to the surface. These pyroclastic flows move rapidly along the ground, forming channels. Since Mars's formation, its surface temperature has been very low. This has made it impossible for a significant amount of liquid H2O to be present. If any liquid H2O had been present, it would have reacted with CO2 to produce carbonate rock. No carbonate rock has been found on Mars. Well, that's all that scientist 2 says. So scientist 2 does not contradict what we know. If it changed from a gas, it started out as a gas up here, and then it changed pressure, the pressure became great enough to change it to a liquid. It changed from gas to liquid. That means the molecules must have gotten closer together. So we have to find gas to liquid and decreasing the distance between them. So decreasing the average distance, gas to liquid, that's J. Decreasing the average distance because CO2 changed from a gas to a liquid. And again, probably a good idea to write down as you go, or lest you forget all this stuff or get it reversed. Decreasing when we go from gas to liquid. So then we found that in the passage. And we did have to check to make sure that scientist 2 didn't contradict what I already know about the distance between molecules and liquids and gases, because it's possible that scientist 2 would have contradicted that, but it turns out that scientist 2 didn't. So 38 is J, 39 is A. I better circle these. 38 is J, 39 is A, and 40 is J. J, A, J for those three.